Hi everyone, today we're going to be talking about how Compunetics can be used to simulate reaction data based on kinetic parameters reported in the literature. So here's our reaction of interest reported by the Rolando group, where we have our benzoic acid A reacting with an alkylating agent B in the presence of base to form our desired product C and some byproduct D. We also have our kinetic parameters which can be used to simulate our reaction data, and we'll start by inputting all this information into Compunetics. So if we go to Compunetics and click on the simulation tab, we can now start inputting this model where we have A plus B as our reactants and C plus D as our products. If we click add term, then straight away this K value in this K value box becomes enabled, and we can start changing the K value. So if we change this to 0.58 per molar per minute, we can change that to seconds as our time scale, and now we can change our initial concentrations. So this can be anything that we want to simulate from. But we're going to simulate from a 1 molar concentration of A and let's say a 1.2 molar concentration of B. So we can instantly see how this changes, how each of the species change over time by checking A, B, C on these OGE plots. And we can see how this reaction profile looks between 0 and 10 seconds. If we want to simulate this reaction further, we can change this to, let's say, 30 seconds, and you can see that the reaction has basically gone to completion rather quickly. If we change this to 60 seconds, you can see that the reaction has gone to completion fully. So because we can use this K value to simulate our reaction at a given set of initial concentrations, what we can also do is we can use our activation energy to simulate our reaction at different temperatures also. So because we have this information, we can click on use kinetic parameters to determine our K value, and here we can change our activation energy and our reference K value at a particular temperature. So we have this at 20 degrees. So straight away, as you can see, the reaction profile is changing as the reaction is now seen as it would proceed at 25 degrees. But we can also change this. So let's say that we want to see how our reaction would proceed at 10 degrees. You can see that the reaction profile changes instantly, and then we can change this to, let's say, 5 degrees. And then we can dynamically change any of these values to see how our simulation changes. We can also change the initial concentrations, and you can see that the reaction profile changes. So this is a pretty simple example, just showing how we can use Compunetics for a one-step model to generate some reaction data, which we can then extract using this extract plots button. So now we can look at a more complex reaction from the literature reported by the Born group, where we have a multi-step, multi-component SNAR reaction between A and B, reacting to make our ortho desired product as C and our unwanted side product of D, which is our para-substituted product. But then both of these species, C and D, also have further overreaction pathways to form this bis substituted product as E. So all of this kinetic information is reported in the original publication, and this has already been inputted into Compunetics as our K1 through to 4. So what we want to do first is we want to change our initial concentration. So again, we'll just put a 1 molar initial concentration of A, and let's put a 2 molar concentration of B. And then for the first 10 seconds we can see how this reaction should proceed for each of the species that we check. So we'll check A, B, C, D and E, so every species. As you can see, the C product is formed preferentially, but there starts to be a little bit of a decline in the concentration of C over time. So we can see how this changes, let's say after a minute, and you can see that this becomes quite substantial over time as E starts to be formed. We can also see how this changes at different temperatures, just as before. So if we want to simulate this at 80 degrees or 70 degrees, then that's possible as well. Or at different initial concentrations is also possible. This simulation can be used to optimize our reaction in silico, or just as a measure of how a reaction should proceed before we actually carry it out in the lab. I hope this has been helpful, and as always, if you have any questions about Compunetics, please don't hesitate to contact me, and the information on how to do that is in the description. Thanks for watching. Goodbye.